In this video, we are going to learn how to classify a system without graphing. Now, the way we do this is we know there are two types of systems. There's a consistent system, which means it has at least one solution, and an inconsistent system, which has no solution. Now, with that statement, at least one solution, there could be one solution or infinitely many, like a bunch of solutions. So if there's just one solution, that's an independent system. And if there are infinitely many solutions, we call that a dependent system. Now, there are three ways lines can exist within these systems. One is that the lines are just intersecting. We talked about in the previous lesson that if they intersect, that is that one solution for the system. So when we have that one solution, we say it is consistent and independent. Now, the two lines could be the exact same line, meaning they intersect each other an infinite number of times. So we have infinitely many solutions, which is consistent but dependent since we have so many. And lastly, you could have parallel lines that never intersect. So there's going to be no solution, and that would be an inconsistent system. But the process of doing this on a normal problem is when you're given these equations to put them into slope-intercept form. So for our first example, without graphing, we're going to label the system as independent, dependent, or inconsistent. So when I put this equation in slope-intercept form, I will add 3x to both sides, giving me y is equal to 3x plus 4. That is in slope-intercept form, so a slope of 3, y-intercept of 0, 4. The other one, we'll subtract x from both sides. I'll have negative 1/3 y is equal to negative x plus 1. I'll multiply each side by negative 3, giving me y is equal to 3x minus 3. So in this example, we have two equations that both have a slope of 3, meaning that they are the same line or they are parallel lines if they have the same slope. They will not be intersecting since the slope is the same. But we'll see here we have two different y-intercepts, one up at 4, one down at negative 3, which means that these are parallel lines that will never intersect. So this system is inconsistent. For the next example, we have the set of equations 2x plus 3y equals 1 and 4x plus y equals negative 3. Now we'll do the same thing. I'll put both of these into slope-intercept form. The first equation by subtracting 2x and then dividing by 3. We'll get a slope of negative 2/3, a y-intercept of 1/3. The other equation, we will subtract 4x, and it's already in slope-intercept form, so y is equal to negative 4x minus 3. Here we have two different slopes, which means they are going to intersect one time. So this becomes an independent system since I only have one solution. And for our last example, we have y is equal to 2x minus 3 and 6x minus 3y is equal to 9. So one of these is already in slope-intercept form, but the other one is not. So we will subtract 6 and then divide by negative 3, giving us y is equal to positive 2x, but then minus 3. And you'll see here we end up with the exact same line, which means they'll be coinciding, intersecting an infinite number of times. So this is a dependent system. And that is how you classify a system of equations without graphing.